This section here is about the structure of the Earth, and as you can see there are 4 distinct layers when we talk about the structure of the Earth. We've got the crust, mantle, outer core and inner core. But when we look at those, we've also got to think about the specific nature of them as we look at them. So we've got the inner core, which is obviously the hottest part, and as we said before is solid, iron and nickel, that we can see. 5,500 degrees, and this is the start of our convection currents, which we'll come on to in a second. Then we've got the outer core, and that is the layer surrounding the inner core. We knew that it was liquid, but not only is it liquid, it's a much less dense liquid than the mantle. The mantle is quite dense. It's like a little bit like the consistency of treacle, as opposed to the consistency of water, which often the outer core is. And then we've got the solid layer on the surface, which is the crust. So we have that, which is also divided into oceanic and continental, and that's the next thing that we're going to come on to. The continental crust and oceanic crust are the 2 types of crust that we have on the surface of the Earth. Continental crust is the oldest type of crust and also the thickest type of crust. However, its density is fairly low, so whilst it's quite thick, it is not very dense. Oceanic crust, which forms most often at constructive plate boundaries, is not as thick, but it is considerably denser. So at plate boundaries like the Nazca Plate and the South American Plate, at that plate boundary, then we have a situation where the oceanic crust is almost forced underneath the continental crust at that particular destructive plate boundary. Both of these crusts slide around on top of the asthenosphere at a rate of about between 2 and 5 centimetres a year. That's about the rate at which they move, so not particularly quickly. This diagram will hopefully allow us to see a little bit more clearly how the plates move from one section to another. So what we've got here is an area of continental crust, so you could call this South America. So that's the South American plate boundary, and then around these regions here you've got an area of oceanic crust, so you possibly could refer to that as the Nazca Plate. And so when these different plates are actually moving, the density of this plate allows it, or forces it in some ways, to subduct underneath the continental plate. So that's South American plate there, and so it subducts underneath. And this area here would be called the subduction zone. Okay, so the reasons that the plates on the surface of the Earth will actually move is all down to what we know as convection currents. Now there is a great deal of heat generated in the inner core, and that's all to do with this idea of radioactive decay. So because there's an awful lot of heat in the core, elements will break down, particles will start to break apart, and they will release particles from their nuclei, and that gives off heat. And that's basically what causes such a massive amount of heat to come from this section. Now when we're talking about lots of heat being created, it's being created in this liquid section here, so consequently you get movement, and you get movement in different ways. So you have these plumes of magma rising up, and then they move across the surface, and then they fall back down again. So it's just underneath that section there. So we've got the crust on the outside, as we've said, and then we've got our asthenosphere at this section here, and so we've got this level of movement occurring. Now they don't all move in the same direction, so we're going to have a look at how convection currents will work in a little bit more of a practical sense. I'll just move this out of the way. So I want us to imagine, here, and you'll have seen this before, that we've got the surface of Earth here. As we said, we've got our continental crust, and we've got our oceanic crust. Now if we were going to put in the movement of convection currents, then what we're going to see is a rising of plumes of magma. And so in terms of direction, that is the sort of thing we are likely to see. So you can see that that's actually showing you the movement of that plate. So if you remember back to when we looked at the tables and we were running around the classroom moving the tables, that is the sort of movement that you would get at this section right here. Now here on our continental plate, so this section here where our continental plate is, we have got a different area of movement. So we've got, it's slightly different. So they're moving in opposite directions. And because they're moving in opposite directions, that is actually causing them to collide at this subduction zone. And obviously the density is forcing the oceanic crust underneath the continental crust. This here is a destructive plate boundary. This is a constructive plate boundary because we've got two continental plates that are moving away from each other. So if I consequently put this section in here, then now you would see this type of movement. Okay.